Testing. Hello, everyone. May I know from our audience if you can see me or if you can hear me? Test sound. Hello to good evening, everyone. Uh, Sound test, video test. Can you see me? Okay, thank you, Ms. Leiva. Hi, everyone. This is Lando Assistant, and welcome to our live program here at Math Avenue. This is our first live program here at our YouTube channel, and I am alone today because my partner, Mr. Herman, is at work today. It's 9 o'clock in the morning here in the United States. It's 9 o'clock in the Philippines, and to all our viewers from different parts of the world, from India, from Africa, from all the different parts of the world, good morning, good evening, and welcome to our live program. I would like to say hi to Ms. Liva, Sir Ralph Amor, Miss Jem Mirinda, Judeline Aguila, Carlin Rome, Daryl Andre Casano, Sam Paraiso, Matthew Charles Lugoy, and to all our viewers. Now, today we are going to have raffle promo. At the same time, we are going to learn some mathematics today. So, in order to qualify for our raffle promo, you should be logged into our YouTube channel and put your comment there because we are only monitoring our YouTube channel. So, all the comments from our YouTube channel, we will be able to gather all your comments using a random picker application. And that's how you are going to win. So, if you are in Facebook, if you are in Facebook group, you can transfer to the YouTube channel if you want to join in the contest. But if your goal is just to watch our math program today, you can stay in Facebook or in the Facebook page. So, how to join, how to win in our uh, contest today? All you have to do is you are going to comment your answer to the math questions that we are going to post. So, this is the YouTube address where you are going to find the live program. So I'm going to post the question and you are going to answer it. And all who write their comments, whether it's right or wrong, you are included in the raffle. That is because I will not be able to select which is the correct one or the right answer because I'm going to use the app. But also in mathematics, there's always allowance for error. What is important is we are participating. And after participating, we want to know whether our answer is correct or not. So I'm going to discuss the answer after posting the question. So also for those who commented in our videos, the last 5 videos for this week, I saw that there are more than 40 in the morning. After a few minutes, I refresh it. There are already more than 60. So you still have time to comment in our last 5 videos here at Math Avenue. And at the end of this program, we are going to raffle 3 persons who are going to win 500 pesos. So let's begin with the first question now. This is an easy question. Just comment your answer. What do you think is the value of the square root of the quantity negative x raised to the second? And timer starts now. And hi to Ralph Tibli, Albertus Nyabi from Congo, Africa. Hello to all our viewers from Africa. What time is it there now? Also to Patricia, Matthew Charles Lugay, Kin Ken, Sherlyn, Carlin Rome, Miss Leiva, Sam Paraiso. They are now answering X, Eugene Reliama, Greg, Sir Greg, Juliet Gasgas, one of our scholars, Grego de la Cruz, Jem Mirindo. She is the leader of the math group in PUP. We have Ralph from Calabanga. So they are answering X. Okay, what's the answer to this question? Now, this is one problem where many students, even teachers, are confused. Here we are going to apply the order of operation. This is how to do this. Notice that this square root means a fractional exponent 1/2. So this means we can write this as negative x, the quantity negative x squared, all raised to 1/2. So this square root is a fractional exponent 1/2. Now, from the order of operation, we are going to perform evaluating this when you have nested exponent from the inside. So you have the square of negative x is x, because negative x times negative x is positive x, raised to 1/2, which is equal to x squared, raised to 1/2, and you multiply 2 times 1/2 to get 1 here, so x to the first, or simply x. Now, the common mistake here is many students would just cancel this and answer negative x. That is wrong. The right answer is to go through this process and arrive at x as our answer. Okay, so that's our first problem. Now, we can contrast that with this problem for number 2. So what about if you now have this parenthesis, the square root of negative x, all raised to the second? What is the difference of that with the first one? Hi to Sir Ngok Lihoy. Oh, he's our outstanding mathematician. His answers are very, very excellent in Assistant and German Academy. Miss Aying Duran, Michael Duran, Andre Casano, Roberto Sir, I cannot read, Sidorifa, Sir Patricio, Emmanuel. If you are from other country, you can write your country. We have some from Sudan, from Africa. Okay, Jason Rubina, Maria Isabel Agustin. Thank you very much to all those who are participating. We have 84 live participants right now. So, in this case, this is how we are going to answer this. This is a complex number. So, we are going to evaluate inside this radical first. We can write this as I times the square root of x raised to the second. And then applying the power of a product, we can raise I to the second to get I squared times the square root of x raised to the second. But what is I squared? I squared is equal to negative 1. And here, the square root of x raised to the second is equal to x. And therefore, our answer is negative x. So this is the one where you can just cancel these two to get negative x. But the exact process is to think of this as one number, which is a complex number, which can be written as I times the square root of x, and we have that answer. So I saw a lot of correct answers. Thank you very much from Calbayog City. Jason is from Calbayog City. Now here's another problem where many students find some confusion. Is the principal square root of 4 equals plus or minus 2? True or false? Hello, Andre Josh, Solomon Duran from Calabanga. Hello to Sir Jose, Dig Salamat, Daryl, Jason, Andre Josh, Joshua Martinez, Jones, Murphy, Carlin Rome. It's fast. It's just going very fast in my screen. I cannot even read some of the names. Okay, so this is also one common misconception or the cause of some confusion in mathematics. If you are computing the square root of 4, is it plus or minus 2? The answer here is this minus should not be here. It should not be included here. Because The principal square root of 4 refers to the positive root, that is 2. If you want the negative, then we should write negative square root of 4, and that is equal to negative 2. And if you want both, we should write plus or minus outside square root of 4. That is when you have plus or minus 2. That is when you are performing computation. It's different when you are solving an equation. Let's say if you have x squared is equal to, let's say, 4. When you are when you are solving equation, when you take the square root of both sides, that is the time when you put plus or minus 4. And therefore here, x is equal to plus or minus 2. But if you are just performing computation, like here, you just want the square root of 4, the answer for that is just the square root of 2. So may I repeat, when we are just performing computation, we need to be specific about our intention. Our intention here is to find the principal square root of 4, and that is positive 2. If we want the negative root, then we should have written minus square root of 4. It should be like that because otherwise, when you are performing now 2 plus square root of 4, and you are adding, you are performing 2 minus square root of 4, if you are going to accept this answer, then these two will have the same answer because you can say this is plus or minus 4, this is plus or minus 2, plus or minus 2. So whenever we are performing computation, we should be specific with our intention, whether it's positive or the negative root. Only when we are solving for the root of an equation, when we write plus or minus 2. This is one common misconception that I notice when we post some videos involving radicals. Okay, thank you very much. So the answer is false. Here is our next problem. Notice that we are just picking some problems where many of us find some confusion. So Sir Renato say, I see, very informative. Zalen, oh, my partner, Sir Reagan Janisha, black belt in mathematics. Hello, Sir Zalen. Next time we'll be going live in your YouTube channel as well. You can put there the link to your YouTube channel. Please visit also the YouTube channel of Sir Reagan Janisha. He is the chief math content creator of Assistant and German Academy. He's very, very bright. Okay, some are answering positive 1. Some are answering no answer, empty set. Can the absolute value of any number be equal to negative 1? That's the question there. Okay, before I answer that, let's recall what's the definition of absolute value. The absolute value of x is equal to a piecewise function that is equal to x when if x is greater than or equal to 0, or negative x if x is less than 0. For example, if x equals 2, then the absolute value of 2, since this is greater than or equal to 0, we take the first part of the piecewise function, then it's just simply whatever is x. However, if x is equal to negative 2, then we have the absolute value of negative 2. Since negative 2 is less than 0, we take the second part of the definition. This is equal to the negative of whatever is inside the absolute value symbol. So negative of this negative 2, and that still give you a positive 2. That's the reason why we have this piecewise definition of this function. Whatever is the value of x here, the answer should always be positive. Now, that's different from here because you have an x, which could be any variable, and we are looking for that number such that when you take the absolute value of that number, that resulted to negative 1. And the answer for this is that is not possible. Because when you take the absolute value, it should always be positive for the answer. And therefore, there is no solution to this problem. No solution. I saw a lot of no solution answers. So you are correct. There is no solution here. So some are also confused. Why do we have negative x here? This is just a way of saying whatever is the number inside, turn that to positive. So that when the number inside, the absolute value is negative, you can turn that to positive by getting the inverse of that, the additive inverse. That means you get the negative of the negative to make it positive. So whatever you do for absolute value, the final result here should be positive. But here, there's a negative one, so it's not possible. No solution. Okay, let's go to some problem also where you can solve, but you need to analyze also if the question is right or wrong. Wow, we have 116 live viewers right now. So thank you very much. For those who want to be part of our raffle draw, please write your comment in our YouTube channel because that's the one that we are monitoring for the raffle promo. But if your goal is just to learn and to join in our math fun today, it's okay for you to stay in your wherever you are right now that you can see this live program. So if x and y are positive integers and 2x minus 4y equals positive 3, then find 16 raised to x over 256 raised to y. This is one of the questions asked in the Scholastic Achievement Test, SAT. Hello to Ralph, to Ma'am Aying, Ralph Lawrence Tube. So these are our original friends of the Assistant and German Academy. Right from the start when we created the page, they are very loyal to our page. Zem Paraiso, Andre Josh, Solomon Duran. So thank you very much to the Duran family. The father, the mother, the siblings, they are always joining our live program. So what's the answer? I see some answer. Some are answering 16 to the third, 64, 3 halves, 5,096. So whatever your answer, you are included in the raffle. We are after learning here, plus the participation. Okay, so let's answer this problem. Notice that 16 can be written as 4 squared. And then we copy the x. So this is 16 raised to x, which is the numerator. Now the denominator, 256, is 4 to the fourth, and that is raised to y. Excuse me. Then applying the power of power rule of exponent, this is 4 raised to 2x. We multiply x times 2. And here, we multiply 4 times y to get 4y. We have the same base, applying law of exponent number 2. We copy the common base, and we subtract the exponent 2x minus 4y. Now, 2x minus 4y happens to be this expression 2x minus 4y, which is equal to positive 3. So by substitution, this is equal to 4 raised to the third, and 4 raised to the third is equal to 64. That is if the problem is correct. Why do I say that? This question is a flawed problem, meaning there's a problem with the problem. So if you are a student who answers 64, you follow exactly what your teacher taught you. But the nature of the problem itself is problematic because you have here 2x to x minus 4y equals 3. Now we can factor out the 2 to have x minus 2y equals 3. What does this mean? This number here is divisible by 2, and if a number is divisible by 2, that number must be an even number. An even number at the left, but an odd number at the right. So there is a contradiction. There is a problem. So I say this question has a problem, but if you're going to apply what we learned about laws of exponent, the answer is here is 64. But what I put here is sometimes teachers also create wrong questions. And the way this question was phrased, the one who wrote the question is not cognizant that there is a limitation here, because when you have an even number, you cannot have that to be equal to 3. So just some comments on the question, but if you follow the laws of exponent, the answer here is 64. Okay? Now, let's try some logarithm problem. So here is the problem. Yeah, the link to those who are asking for the link to the YouTube channel is www.youtube.com/@mathavenue. Or if you are at YouTube, just type at Math Avenue, you will go to the channel. Okay, here's the next question. Also, you can see from my name here that my name is youtube.com. Oh, it should be slash at Math Avenue. I forgot the word slash, the symbol slash. Okay, here's the next question. What is the logarithm of 5 to the base x? The logarithm of 5 to base x is equal to -1/2. What is the value of x? Can the exponent be negative? So hello to Matthew, to DK, to Andre, to Judate. That's a nice name, Judate. To all the sagabos pong mga Bicolano na nagdadalang ngayon, maray na banggi po sa Nagabos, taga Bicol po ako. So to Sir Darrell, Sir Mom Jem, the common answer is 1/25. Someone also answered the square root of 1/5, the square root of 1/5. There is no solution. Some people are now doubting whether the problem has an answer, because I gave several examples where the problem was problematic, where there is no solution. But I would say there is a solution to this one. The only limitation when you are taking logarithm is this base could not be negative. But here, the -1 is the exponent, so there is an answer here. The reason why we cannot take a negative base is when you have a negative exponent and you have a radical that's raised to an even exponent, then that will result to an imaginary number, which is not covered in most high school. When you solve for a problem where the domain is not stated, the assumption is you are solving it for the set of real numbers. But in the set of complex numbers, we can always solve that. So how do we solve this one? So first, we just use the definition that logarithm means exponent. That means this 1/2 in an exponent, a base x. So the base is x, the exponent is -1/2, and that is equal to this 5. Then when you have a negative exponent, that is just written as 1 over the base raised to positive exponent. You can also do it like that. Or before you go here, you can already multiply this by -2, multiply this by -2 before going here. And -1/2 times -2 is 1. So you have here x. And here you have 5 raised to -2, which can be written as 1 over 5 raised to +2, which is equal to 1/25. So a lot of you got the correct answers. So this is now our 5th question. We have 3 or 4 questions left. So let's proceed now to the next question before it gets too late for all of you there in the Philippines. I know it's nighttime there. So let's try some geometry problem. Sir Reagan wants 2 rectangular enclosure against his house. So imagine he has a fence. So let's draw that. He has a house here, and he wants to have 2 rectangular enclosures against his house. He has 600 meters of fencing. What is the dimension that gives the maximum area, and what is the maximum area? So this problem is very applicable when you are maximizing your space, when you are minimizing your fencing. So some problems like that. And this also a problem on optimization, which is the theme when you are in business. You want to minimize the cost, you want to maximize the profit, you want to maximize the use of your land. I see Sir Matthew has an answer of 90, what's that, 9,000 meters squared. Hala, ang galing, ang bilis. We're going to slow down. So probably we are doing it so fast. So hello to all our live viewers. We have done 100 live viewers right now, and soon we'll be doing our raffle. Yeah, this takes a little time to analyze, but this is not very difficult to solve. Some might use calculus, some might use quadratic equation. Some, you just need to remember what is the formula to find the vertex of a quadratic equation. And the hint there is the x-coordinate of the vertex is negative b over 2a. Sir Mom Carlin said 150 square meters. Sir Diggs 5,700 square meters. So Sir Regan, we are helping you maximize your lot. Some answered 28,800. 150 meters by 300 meters. Sir Mark Julius Salva. Sir Mark, where are you from? And Judith says 150 square meters. When I say dimension, that's the length and the width. So we are expecting like two numbers. What is the length and what is the width? And then for the maximum area, you multiply the length times the width because the shape is a rectangular shape. Let me just check the time because I don't want you to stay too late. Jose Ferreira, wow, we have the complete solution from Sir Jose. Thank you so much, Sir Jose. I really appreciate the effort, and he has the answer there. And then Solomon Duran, 150 meters squared. Sir Diggs said 570 by 10. Okay, while you are answering that, you can answer that together with me. So I just need some sketch work here. So we want the fence to look like this. We do not know what is the length. Let's say the measure of this part is x. Since this is a rectangle, opposite sides are equal, so this is also x. And this side here must also be x. That means if you have 600 meters of fencing, you are going to subtract 3x from 600. That is the remaining part here. Notice that you only need fencing here, here, and here, and here. So you have a total of 600, but you are going to subtract the part that you already used. You have x, x, x. You already used up 3x. So that is the width. The length is x. Therefore, the area is equal to x, which is the length, times the width of 600 minus 3x. This will give us the area. And simplifying, this is equal to 600x minus 3x squared, which is a quadratic equation. Okay, so what kind of quadratic equation is this? Since the coefficient of the x squared term is negative, we know that it is like this. Roughly, it's like that. The y-intercept is 0, so it passes through here. The maximum is at this vertex with a coordinate of x, y. But that coordinate, the x coordinate here, can be computed using the formula negative b over 2a. This will give you the x coordinate where you have the highest value of this function. And this is equal to negative 600 over 2 times a, which is negative 3. This gives us 600 over 6, which is equal to 100. So the length is 100. This is 100. What is 600 minus 3x? That is 300 here, 600 minus 300. This must be equal to 300. So the dimension is 100 by 300, and the maximum area is the product, 30,000 square meters. So that's the answer to this problem. Okay? Okay, this is an interesting problem. Next problem po. Okay, so here's the next problem. Our engineers would love to solve this one because in engineering, especially electrical engineering, the set of complex numbers is a necessity. It's very, very important in applications. Sir Salen said the maximum y value is c minus b squared over 4a. That's correct, sir. And you can also get that by substituting the result for x to the equation. Teacher Ray said, well explained, very helpful. Thank you so much, Sir Ray. Teacher Ray, I appreciate that po. Hero Robles say hi. Okay. Adrian de la Cruz got 100 meters by 300 meters. That's correct. So this is a challenging, at the same time, very interesting problem. Whoever thought of getting the ith root of the imaginary number? So we have square root of negative 1, which is a complex number. So we need a little time here, so you can give like few minutes to answer this. I got some feedback that we are so fast. Again, for those who want to join our raffle, we are going to raffle all those who commented in our YouTube channel, because that's the one that I can monitor right now. I'm using that app where I can link to the YouTube channel and get all those who commented, and we can randomly select 3 winners from all those who joined the commenting of this post, the live program, plus all those who wrote their comments to our previous videos, the last 5 videos for this week. So you still have time to participate in the raffle. You can still comment in our YouTube posts, the last 5 videos there. When I refresh, you'll be included in the raffle. So we have some answers of LNY, some answers once. Ma'am Leva said not sure. There's a negative one. So I'm picking some questions where we really need to think. It's simple, but it could be problems on critical thinking. Some answers, the natural number e, Sir Diggs. Jem said 1. This is connected to the most beautiful equation in mathematics. Remember that equation involving e, I, pi. Okay, we can solve this together. So let's recall that I, what's the value of I? That is the square root of negative 1. Then a complex number can be written in the form z is equal to a plus bi or ib. Usually we write it I first, then b. Especially when you have radical, it's easier to write the I first. So visually it looks like this. This is the complex plane. The horizontal is for the real part, and this is for the imaginary part. Okay, where is negative 1? Negative 1, where is I? This is 1 here, this is I, this is negative 1, and this is negative I. If we have a point, let's say Z here, we can express that in the rectangular coordinate, A is the real part, B is the imaginary part, or we can also express that in the polar coordinate where we have a positive number here representing the radius, and we have an angle here represented by the angle theta. Now, usually it's easier to work this problem in the polar coordinate. So in the polar coordinate, this is now equal to C equals R times E I times the angle. So these two are equivalent. One is describing the same point using the rectangular coordinate, whereas this one is using the polar coordinate, a series of concentric circles. R is the positive radius. Now, we have here negative 1. At negative 1, what is this angle? That angle is pi, because the radius of one circle is 2 pi using the unit circle. Half of that radius from here to that is a semicircle. This theta is pi. So at negative 1, this is equal to r e I times pi. Okay. Now, we also know that e raised to I theta, this is I, is equal to cosine theta plus I sine theta. So this is, we need some paper. This is an identity. So what can we do now from here? We are here at negative 1. So we want this negative 1. How do we represent now negative 1? We now have the ith root of negative 1 is now equal to the ith root of the equivalent of negative 1 in the polar coordinate, which is this one. That is r e I pi. But notice that if I move one more rotation, I complete one more rotation, I will still arrive at the same result. In other words, if I keep moving around the circle, I will keep going to this point, and therefore this pi should be added by a multiple of 2 pi. 2 pi, but since we keep on rotating, we multiply by a factor of n, where n is an element of the set of integers. So we now have here the ith root of r e I pi, I times the quantity pi plus 2n pi, where n is the element of an element of the set of integers. We add this one because of the fact that every 2 pi we go back to the same point. But what is the radius here? Going to negative 1. The radius is is positive 1. The radius is always positive. So this r is positive. So we have the ith root of 1 e I times the quantity pi plus 2n pi. And therefore, since we have here a radical, we can write this in exponent, fractional exponent, as E I times pi plus 2n pi raised to 1 over I. So from radical to fractional exponent. And now, multiplying these two exponents, we arrive at E pi plus 2n pi. And this is now our answer. So some would just answer e to the pi. This is the principal answer. But we need to remember that we have to rotate around the circle. Okay, so this is now our answer. So some are you are interested to join our raffle, you can move to our YouTube channel for your comments so you can join in a raffle. Okay, we have the last two problems and then we'll do the sixth raffle draw. Okay, this is a problem that is always requested in our messenger account. Yeah, it's a long solution. I'm going to upload a video on how to solve this in our Facebook and YouTube channel. Some people might think this one involves a lot of computation, but actually it's just a matter of looking at the logic. There's some computation, but it's not that difficult. So, hello, Sis Daryl Yusan. Hello to Mami Dalia Juices Yusan, the mother of our academy, the sister of our academy. Thank you so much for participating. And we also have Sir Jones, Zem Paraiso. We have R.R. Placido Jr. When I say Facebook user, that means you are commenting in our Facebook group. There's some bug still in the application of the StreamYard. It says Facebook user. Then hello to Mark Salva, Jester Soriano, Adrian de la Cruz, 80. The common answer is 80. Some are answering 4. Okay, Daryl said grabe yun, and Zem said such a long solution. So Laiba said very fascinating problem. Okay, Sir Hero said 80. Common answer is 80. Looks like a lot of you already are finished answering this. So in 30 seconds, we'll solve this problem together. I am mindful of the time because it's getting late there in the Philippines. It's 9:44 a.m. here in Maryland. It's 9:44 in the Philippines. We have some from India. Let me check what's the time in India right now. Currently, it's 7:14 p.m. in New Delhi, 4:44 in London, in Istanbul, 2:44 in London. In Australia, 11:14 p.m. Okay, so how do we solve this problem? A lot of you answered 40. That's the correct answer. So it takes 5 men. So let's answer it. It takes 5 men, 4 days to dig a 100-foot train. So this is the work done, 100. 5 men for 4 days, and those men have their corresponding rates. We do not know how fast they are. So multiplying the number of men times the number of days times how fast they work, that is equal to the work done, which is digging a 100-foot train. So multiplying now 5 times 4, we get 20 man days. And solving for rate, the rate is equal to 100 over 20 man days. So 100 feet per 20 man days, or we can simplify this to 100 over 20, which is 5 feet per man days. Now, let's just remove the unit in our computation to make it simpler. Now, how many men are needed to dig? So we do not know the number of men. Let's write M. Are needed to dig a 200-foot in 1/2 day. So the number of days is 1/2. The rate we know is 5. This is equal to the work done, which is 200. So 5 times 1/2 is 2.5. So it's like 5 over 2m equals 200. And so multiplying by the reciprocal of 5 over 2, we have 200 times 2 over 5. And this will give us 80. So the answer is we need 80. That's the number of men. And a lot of you got it correctly. So the answer is 80 men. Okay, here's our last problem before our raffle. This is again a requested problem from one of our followers sent to our Facebook Messenger. So Adrian got it correct. Jem got it correct. Dr. Ngok got it correct. I call Dr. Ngok because for me, he is PhD in mathematics. He's very, very good. Sir Mark is correct. So very, very good. Now a sum amounts to 3,600 at 2% per annum or per year under simple interest, and $4,800 at 4% per year under simple interest. The time of investment is blank years. Okay, all those who commented in our in our YouTube channel, you are included in the raffle, whether your answer is correct or not. So it's the participation that we are counting. Everyone has a learning curve. Some are not yet that good. Some are also just not so careful with the computation. We are here as a community to learn mathematics, and we are participating as a group. So everyone who are in our YouTube channel and you wrote your comment, you are qualified for the raffle draw. So we are switching our live program from the YouTube to the Facebook because we got some feedback, because we are just focusing right now in our Facebook channel at Assistant in German Academy. But there are some schools where students cannot log into their Facebook, or some teachers cannot log into their Facebook. So they requested for a YouTube channel where they can open anytime. It's easier to find where the videos are. Plus, they can download if necessary, because it's easier to download videos in YouTube. You just need some third-party apps there to download videos from YouTube. Sir Joshua said, so nice, very healthy community. Yeah, this is just my off day, so I'm doing it Wednesday. Mr. Herman is working right now. It's almost 10 o'clock here in North America, so he is not able to join. Plus, I would like to give our scholars the chance to join in the raffle also, so they are participating in the raffle right now. And two of our scholars just graduated this week. Miss Judeline Aguila. Oh, then another one is graduating. Miss Rafi Francisco, plus five more at Sibiswa Calabanga. So we have 7 graduating this June. And all the support that you are doing for our Facebook page, for our YouTube channel, we use that to support. Currently, we now have 23 scholars. So all the money that we are getting from these channels, we support to our 23 scholars. So by watching our video, you are supporting our scholars. At the same time, we are participating in a community that wants to learn mathematics. Okay? Yeah, the answer is 25 years. How do we arrive at 25 years? So we need some scratch work here. Let's recall what's the formula for interest. Interest is equal to principal times the rate times the time. The final amount is equal to the principal plus the interest, and therefore the final amount is equal to P plus PRT, which is the interest, which can be simplified as P times the quantity 1 plus RT. So we need this formula because what we now have here is 3,600. That's the amount. So therefore, for our equation now, we have two amounts here. One is 3,600. Let's call that as A sub 1. And our second amount, A sub 2, is $4,800, 4,800. So this is, the first one is at 2%. The other one is at 8%. Oh no, at 4%. Therefore, we can compute for A. So we have 3,600, that is the amount, times the principal that we do not know, times 1 plus the rate of 2%, 0.02, times the time that we do not know. So the time is per year. So that is the first one. The second one is 4,800 equals the principal, P, times 1 plus the interest rate of 4%, which is this. Now, let's take these two equations simultaneously and let's get the ratio. Let's divide both sides, both equations. So 3,600 divided by 4,800, that is 3 over 4. P divided by P is 1. So we have 1 plus 0.02t over 1 plus 0.04t. So we now work on with this equation. So by cross multiplication, that is multiplying by the LCD, so multiply this to 3 times 1 plus 0.04t, that is equal to 4 times 1 plus 0.02t. Distribute the 3 to get 3 plus 3 times 0.04 is 0.12t equals 4 plus 0.08t. Now gather similar terms, like terms. So we have 0.12t minus 0.08t is equal to 4 minus 3. So we gather common of the constants and the terms with variables. 0.12 times 0.08 is 0.04. Copy the common variable t equals 1. And therefore t is equal to 1 over 0.04, and this is equal to 25. So T is 25 in years. So that is our answer, 25 years. So we are now ready for the raffle draw. I saw a lot of correct answers. If you want to join the raffle, you can write your comments in our YouTube posts, the last 5 videos, plus this live program in order to win 500 pesos. So you can win both in the live program and at the comments. So if you participated in commenting in our videos for the week and you won in that category, you can still win in our live program because these are two separate categories. So one person can win a maximum of 1,000 pesos today. So let's do now the raffle draw. I'm going to share with you my screen because that is in this screen. And I'm going to the place where the raffle is to be done. So this part where we gather all those who wrote their answer in our comment section. We have 61 right now. I'm going to refresh this and let's see how many do we have. We have 66. And we are going to select 3 from this and the other 3 from our live viewers. So let's select first the 3 winners from those who participated in the like, share, and comment our YouTube channel. Honestly, we are promoting our YouTube channel, www.youtube.com/@math avenue. So we are late in the game. We are just starting to focus on our YouTube channel as well, on top of our Facebook page, because we can reach more people also in YouTube. Plus, it's easier to find some of the videos in YouTube. So if you want to join, please subscribe to this channel. And every week we are going to have a raffle of those who are participating. So here's now the winner. We are going to select 3 here. Let me refresh because there might still be some who just joined. There's 1 added. So here's the first winner of 500 pesos. And that is Vincent Yang. So John Vincent Yang, you won 500 pesos. Here's the second winner of 500. And the winner is Jem Christian Lazo. The comment was great. And the third winner is Jovita Alvarado. This is her comment. So these are the 3 winners for our for our YouTube videos for this week. Now for the live viewers, so let me get all the comments. I'm just refreshing. Wait, there's still a problem. So this is our live program. And I'm going to get the one who commented in this live program. So I get just give me a little time to get all the names. So I'm just refreshing. So thank you very much to all those who are participating in our YouTube channel, www.youtube.com/@mathavenue. So I'm going to paste here the link, and here we go. Oh, wait. I'm having some problem getting all the comments. It programs. Yeah, I'm just getting all the names here. Wow, there's a problem. It says disabled. Why is it disabled? I'm very sorry. I'm just getting all the names. I have to just refresh probably. So this is the first time I'm using this app to do the raffle. So it works the first time, so it should be working here. So what I need to do is get the link. I copy the link. Let me remove this. I'm sorry for wasting your time. I'm just trying to fix this problem here. So we have the. Wow, I have problem. uh, Let me log in again. This video has comment disabled, so I did not disable the comments. Yeah, if you have problem, what I'm going to do is I'm going to go back again to show you the raffle, but I'm trying to fix this. I'm so sorry for all these problems, but let me do it one more time. So this is our page. Yeah, I have a problem getting all the names, and I'm sorry for this, but I'm going to fix this one, and I'm going to upload a video of me doing the raffle once I fix this one. I'm so sorry for everyone who are waiting for the raffle, but just give me a few minutes and I'm going to fix this. And I don't want to make you wait this long. So I'm going to end this live program, but I'm going to show you the video of the raffle once I fix this right away. So again, thank you very much for, let me find out. So I'm sorry for the glitch, but I'm going to fix this po. I'm going to see what's the problem. And once I fix this, I'm going to make a video and I'm going to let you see how I do the raffle live here in our YouTube channel, in our Facebook page. So again, thank you very much for joining us today. But again, I'm so sorry there is a glitch in this second part of the raffle. But don't worry, all the comments that you have there, all those who participated, I'm going to upload to you the video of the raffle as soon as I fix this one. It says there's some problem with the comment privacy, something like that, but I'm going to fix that as soon as possible. And again, thank you very much for joining us today. Thank you very much for all those who participated. Congratulations to the 3 winners in our share, like, and comment in our YouTube channel, plus our winners in this live program. You will get to know the result as soon as I fix this. So again, sorry, sorry po, but we'll be able to fix it. So again, for those who are not yet subscribed to www.youtube.com at Math Avenue, please support our YouTube channel. We are using the amount that we are collecting from Assistant in German Academy and from this YouTube channel at Math Avenue to support our scholars. And right now, we now have 23 scholars. Some are graduating in college, some are still in high school, but it's because of your support to our community. So for now, thank you very much. And again, po, sorry. We will be able to fix it as soon as possible. So I'm going live again to show the winners of the raffle. Bye for now.